This video is to show the importance of power management in RGB lighting. RGB lighting is parallel, whether that's pixels or smart or basic or dumb. So in this demonstration, what we have here is we have a 350 watt power supply. This is more than able to supply all the power for these pixels. We have a Holiday Coro pixel controller. And then we have four 50/50s. These are 12 volts. There are 20 strings each, so we have 20, 40, 60, 80, 100, 120, 140, 160. Now, the maximum is actually 170, but we, for simplicity, just have 160 here. Now, this is all running from one controller, from one power supply. There is nothing being injected to the very last end. Now, the first thing you're going to notice here, there is a clear difference between the first and the last string. So we're going out, coming up, going down, over, and then to the end in the back here. This is the last one. As you go through them, you can see that they get dimmer and dimmer, and these look orange. Now, they're receiving the exact same signal, which is white. Now you can see these first set perfectly fine. They're definitely white. So let's do some quick measurements. What we have here is we have a meter. We're going to go ahead and just measure the power coming out of the controller. Now, you can see it's 11.9. What I'm going to do is I'm just going to go ahead and temporarily disconnect this so we can look at the no load power coming out of the controller. We can see that we have 12.6 volts. So just plugging this in, we're going to go ahead and again measure it. 12.6. We've now dropped to 11.9. Now, these end strings are also affecting the upstream strings. So for example, if we just go here and we break this, these actually become brighter all of a sudden. So let me go ahead and reconnect it again. See how they drop slightly? It may be hard to see on the video, but it does brighten up. These brighten up slightly. So let's go ahead and measure the power coming out here. So here we have 5.91 volts. So hardly any power at all. So let's go ahead and hook these back up. We come over here. We'll measure the power on the last string of lights. We have 4.2 volts. So that's just not sufficient voltage to generate the color necessary. And in many cases, if you drop too low, and surprisingly this actually is still running, it can actually stop them from functioning correctly. Now, we've got worst case scenario. When you're measuring your current, you should always do your testing in white. That's the worst case scenario. That turns on all of the LEDs, consuming the most possible power. So, issues to be concerned about: the gauge of the wire, how many you have, what voltage, and we talk about voltage drops in some of our other blog postings. You need to keep this in mind. Now, how do you solve these problems? There's a variety of different ways. One is you can purchase pixels with larger power inputs. With larger power wires, so that the actual gauge of the wire is larger, able to handle more current. You could also inject power. So for example, we could take this and actually take the power coming out of the power supply, come over and plug it in on this end, not hooking up the data, just the power. That will provide power on both ends, basically equalizing the voltage or the current. So when you're doing your pixels, we highly recommend always testing. Each one of these circumstances is going to be different. How much leader cable, how much spacing between each one, the current supply of your power supply, the coldness, the heat, all these factors have a play, and the only real way to know after you've done some of the basic math as to whether or not it will work is to actually hook it up and do some testing on your own.